All right,
Rook.
let's talk about Rook.
Um, so there's supposed to be a general. There's supposed to be a Rook session, not just a manager Rook, right? Not just a manager module.
Yeah, I think it can be either or both, depending on how much we have to discuss.
Travis, do you have
Right.
some ideas too?
Or just as far as the focus, it's really around Quincy planning, right? That's the whole purpose.
Yeah. Yeah.
Right. Okay. Yeah. I think the manager module is a good thing to talk about. Otherwise, I think just had some general thoughts about planning, but no real specific features other than learning about what Ceph is doing in Quincy, so we can make sure we expose those features coming up. I don't know. Do we want to jump into the merge or the module, or is there something else first somebody wants to cover?
I think that makes sense.
Yeah.
Sounds good. Yeah, I think a month or two ago we had a meeting on this topic with Juan Miguel. You're still here? Yep. And others about what we want to do with the module and the scenarios around it. And I think we came away from that discussion wanting to understand the scenarios better for where we really need to support it. And I guess my question is, do we have a better idea today of like the dashboard scenarios where we really want to drive Rook? Because I don't think the module should do everything that Rook does, right? But does anybody have some scenarios they'd like to talk through there?
I think the manager Rook module is more or less about the dashboard.
Yeah,
To
I agree.
build the bridge between the dashboard and Rook. Not so much about the CLI. So
I think it's mostly the dashboard, but I think in some cases for the CLI, yes, because we would like the Ceph documentation for scenarios like how do you deploy NFS or how do you deploy a new RGW zone, or like if we can make those work, that would be great. And things like replacing a drive, like if we can document the CLI commands that you do to do that and have them work with Rook as well as with Ceph ADM, then that would be fantastic.
Mm-hmm. Yeah, so kind of a list of targeted scenarios like that makes sense. I think if, what about day one scenarios like just creating OSDs and things that I feel like creating those OSDs would be a more complex area to try and support.
Yeah, especially as Rook is going to remove drive group support. Already gone. Perfect. So which means that it's going to be super awkward to implement OSD support to the Rook Manager module.
Well, I guess it would have to be done differently through the CRD.
Yeah. So either we adopt the existing dashboard way of deploying OSDs to also support this kind of Rook way of doing things, or we just leave it out for the moment. I mean, if we wanna support the Rook way of doing things, we have to extend the orchestrator interface between between the dashboard and the Rook Manager module to accommodate how Rook does things.
Well, I mean, what is the new Rook way of doing things? Like, I know it's using local PVs, but that's about all I know. Like, how do you tell Rook how many and which devices to consume?
Right. There's primarily two different ways. One way is you can just tell it to go look for all the available devices and consume them. Or also with raw devices, you can tell us a list of device names or basic properties. Well, names is really the only thing there. But the preferred way really is with PVCs. So if you have any any sort of PVC, whether you're running in a cloud provider like AWS could give you a GP2 PV. You can tell it, yeah, go create the OSDs after you generate the PV, or dynamically provision a PV, I should say. And then Rook will create the number that you tell us, and we'll try and spread them across the cluster evenly. And I mean, it's basically that you can dynamically provision them, and Rook goes and creates them all.
Yeah, we would need to expose those PVCs into the orchestrator interface and then to the dashboard.
Yeah, that needs to be like a whole new, because it's totally different.
We just need to get the storage class, not the PVCs, because we do create the PVCs in Rook. So the only thing you tell us is which storage class to use, then count, then size, and whether or not you want a storage class to act as a WAL or a DB or both. And then we go ahead and create the PVCs that you need, and then bootstrap the OSDs.
Yeah, but that's a new feature of the orchestrator interface to provide, and then that has to get surfaced all the way up into the dashboard. So it seems to me that like right now the dashboard has right now it has one way to create OSDs, it's the drive groups. But I think the other way that we should add is when you're looking at like the device list, the device inventory of the physical devices, you should be able to just say like create an OSD on that device. Like I see it, it's available, use it, create OSD. That probably can be done with Rook also, right? Because that's actually not going through the PVC interface, or maybe it is, but maybe that's hidden by the details. But if Rook has a hardware inventory,
process.
Yeah. But it seems like that's the thing that.
What's the preferred way of creating OSDs in Rook? That's PVCs, right?
I'd say moving forward, but like in the field, it's more like the opposite, because not everybody has moved to have a local storage operator for people deploying on the cloud.
Oh, you're breaking up, Seb.
Oh crap! Take it away.
Yeah, I guess my summary is upstream users. Yeah, they just find it so much easier just to say, just go consume the devices on the nodes that I tell you, and use certain filters maybe to look for certain devices. But the upstream users, I'd say, aren't using the PVCs very often, unless they're running in a cloud provider.
Mm-hmm.
So there's that simplicity of just avoiding the PVs, I think, is attractive to a lot of people. And in that mode where we're not using PVs, we also have a way to discover what devices are there. So then, and the dashboard at one point was going to consume that. I don't know if it ever did, or the Rook module does, I guess, as far as retrieving what devices are there, so you could choose them and then turn around and create OSDs on them.
Yeah.
One question about the current support of the orchestrator CLI. If we currently run this, I just placed this parity between Rook and Ceph. If we currently run this supply OSD, what is the? I know what is the expected behavior, but what is the current behavior in Rook? Is that working or is it broken?
Sorry, is what currently working? I didn't follow the question.
No, as there's been this change, right, in the no longer supporting the drive groups. If we run this command, the supply OSD, what is the outcome of that command? Is that going to break or is it going to work?
I think that it is working for very, very simple cases, okay? When, for example, you are using a host on a device, okay, and this is working. But I haven't tested, for example, what happened with more complex drive groups. But I think that is in this moment, this is the situation in all the Rook orchestrator, okay? Maybe we can start to evaluate what is the damage control, okay? And to see all these things are working, all these things are not working, okay? And see how we can start again with, providing this functionality. What I think that is important is that, I think that we need to be focused in and keep the API provided by the orchestrator, only one API in order to work with bare metal or with Kubernetes clusters, okay? Maybe things are going to be a little bit different because we are not in control of the infrastructure in the case of Kubernetes clusters. But I think that this is the way. But I think that the most important now is just starting to work, doing evaluation of what is our current state and prioritize the things to do. I would like also to have a session together, okay? The Rook people and the orchestrator people and the dashboard people in order to show how we are doing the things now using, for example, the dashboard, okay, with a bare metal cluster, and see what are the possibilities in order to adapt this to a Kubernetes cluster. Because I think that in this moment, well, we part of the people is aware of what is happening in the orchestrator and in the bare metal world, and there are other people that is aware of what is happening in the Rook world, in the Kubernetes world. Okay, but we need to spend some time together in order to get this more general view. It's my view.
Yeah, and I think that's going to be a multi-hour discussion just to fully understand what all the different cases are.
Yeah.
But I think also, I mean, and I'm not sure it's even clear in the Ceph ADM case, the non-Rook case, as to what are we trying to accomplish, with the dashboard, right? I mean, to me, it's all about ease of use. I mean, I would even include day one, basically we've always got I think a knock against complexity of install, right? So, I mean, would it be nice and, independent of whether it's Kubernetes based or Ceph ADM based, do we want to have a day one that's really easy to install for a class of users, right? I mean, and I would love to see that personally in the dashboard, but that's not something that's been prioritized. It's not something we're driving. I'd love to see that. Then go on from there. What are the high level workflows we want to try to accomplish from a day two? We put together something a while ago. I think we just viewed it internally. We tried to share it outside. I'm not sure how many people looked at it, but I'd love to have that kind of discussion and figure out what are the workflows we want. We have a limited set of resources and dashboard, and I'd love to see both Kubernetes-based and Ceph ADM-based deployments probably have the same functionality. But is that what we want? I don't know.
Hey, I mean, there'll always be a few differences because of, if Rook is on a cloud provider, for example, then these are all dynamically provisioned devices. But yes, aside from those things, we should try to make it as similar as possible. I agree.
Yep.
Well, I wonder if it makes sense to table the OSDs for the moment, because that's like the most complicated part. And it seems like the low-hanging fruit here is to make sure that we have parity in the implementation of all the other OS services in the orchestrator layer, so that you can deploy RGW zones, you can deploy NFS servers, you can deploy the manager, MDS file systems, all that stuff. Make sure all that stuff is working. Working properly.
Making sure all that stuff is working, we really need a tautology integration of that module.
Yeah, that's where I was going. So having thought about this a bit this last week, I'm kind of thinking that we should just bite the bullet and write a tautology test that deploys Kubernetes with Kube ADM.
Yeah.
So that we can deploy a Rook cluster through tautology and have this as part of our normal meta regression test that we do with all the orchestrator layers and stuff.
Otherwise, we will never be able, if we are, if the Rook manager module still works. I think by now it's really mandatory to continue even looking at it.
Yep.
Right, because when we run the tests in Rook, we do have some manager tests against Ceph master, but that's after it's already been merged to master and something sooner.
Yeah. Exactly. I don't think it'll be that bad, honestly. So we'll see. At least some work.
Yeah, but I agree. It's like in a perfect world, we would have the dashboard driving everything through the manager module. But at the end of the day, we have to prioritize. So starting with day 2 scenarios and specific workflows will just be a good way to prioritize. So I think that sounds good.
Yeah, I pasted one of those in the chat. Maybe we can discuss this more in a separate call, more detail. But one of the things we want to do for Quincy is have more automated reformatting or reprovisioning of OSDs. For example, when we have on-disk format changes that require you to take the OSD offline, run some commands, and bring it back up again. These can take a few minutes, and it'd be nice to be able to do this in a shared way between Ceph ADM and Rook.
Yeah, I think it's true for all the components too, like the months as well. Typically, I've been thinking about this with some of the issues we had with the compaction of the month store. So it would be nice to get the month offline, do something, and then bringing back up. Yeah, so yeah, it works for months as well.
Yeah,
I guess.
Yeah, kind of maintenance hyper mode, perhaps.
Right. Yeah.
This is also not just for like a single host, but also kind of to do this across the whole cluster over time. So like as part of like an upgrade sort of step.
Yeah, like pre-hook, pre-update hook or something.
Yeah, I mean it doesn't have to be necessarily part of the upgrade between versions, but it's similar to an upgrade in that you want to roll something out across the whole cluster without disrupting the availability.
Yeah, I mean, so they're
like a maintenance task. Yeah. Okay.
The initial driving motivation here is that Blue Store needs this like FS check whatever to run in order to convert the OMAP to the updated format. And we didn't do that by default with the Pacific upgrade because it is super slow. But you can imagine other things too. Like it might be that you want to just actually reprovision OSDs entirely, like delete,
like converting them to C store later, for example.
Convert them to C store later. Or maybe you have. I mean, if we were having this conversation 2 years ago, it would have been that we want to convert file store to Blue Store. We can't really do that because we don't support file store with Ceph ADM anyway, so it doesn't really matter. I'm a little nervous about or unsure about that case because in my experience, the times when you like really want to like repave OSDs, it's because the whole infrastructure around like how you divvied up your devices, like maybe you have an SSD that's carved into like partitions instead of LVs or something like that. Like you really just need to remove all the OSDs on the host and like wipe all the devices and then start from scratch on that whole host. And it's less clear to me that it's going to be the same workflow or that it can be easily automated in the same way that.
I think you might want to take a similar approach when you're converting, I guess, groups of OSDs or single OSDs, right? Like for those kinds of scenarios, if you're converting whole stores, you might want to do that a host at a time rather than a single OSD at a time.
Right. Yeah, I guess but it's a different.
I think it's different workflow. Yeah. If you touch the drive, like if it's just about changing the initialization sequence of the OSD, and then you just bring a different init container, you do your stuff, and then you run the OSD. That's easy. If you want to revamp everything, like I was thinking about something else, like if you want to encrypt the disk, for example, which is similar to switching from Firestore to Blue Store and everything, then you have to touch the drives. So it becomes an entirely different workflow.
Yeah. I wonder if for the first part of this, like it's what we really want is like an orchestrator command for FS check pair that will stop the OSD daemon, run FS check.
It's not just FS check; it's also several other commands that you want to do, like Blue Store, actually resharding. You have to run the Blue Store tool. There's like several different things.
Oh, right. If we do, yeah.
Like, I mean, even so, there's going to be like dropping the allocation metadata from XTP, so it's not just a single thing. We kind of want a generic way to stop a daemon, run some command, start it up again.
Yeah. But I guess there's still separating the cases. In one case, it's an OSD as it currently exists, dealt with as an individual, stopping, doing some stuff to it and starting it, versus like destroying and recreating OSDs, which I think is going to be different.
Yeah, sounds like those are kind of different paths.
Yeah.
I mean, if we want to add more init containers to the current sequence, then I think it's easy, because this, what you're talking about, essentially comes from an upgrade. So when you upgrade, you go OSDs or host by host, so you always wait in between, so it's fine. But then I think you can be in a situation where you always run those init containers. For example, in Rook, we always run expand BlueFS, just in case the PVC size changed. So we will just automatically resize the BlueFS. Then we could do the same for resharding once that's done. So that seems relatively easy to achieve.
I'm just trying to think how this would be abstracted into something that the orchestrator would run. Like, I wonder if it's if the way to think about it is as a maintenance task, and you define a series of different maintenance task types. One maintenance task would just be fscheck. That'd be sort of the simplest one. But you could have one that's reshard, or one that's whatever. And either of these would be something that it has to be like built into the manager module or the orchestrator module, so it understands it already knows what that particular task is and what the specific commands are in order to accomplish it, or it's something that we let, like you feed in a script template or something like that.
So they're recurring tasks. They don't always necessarily run after upgrades. They will have to run periodically, the resharding, for example.
Well, I think it would initially. I think the primitive would just be something that you would manually trigger. Like that would be the very first thing. Like, go do this maintenance task on this OSD, and it would stop the daemon, run the maintenance task, gather success, failure, and/or log, and then start it again. And then there'd be something on top of that that would automate it. Like if you want to reshard every OSD in the cluster, then it would carefully decide whether it's safe to restart this OSD, just like upgrade does, and then run that maintenance task and then continue.
Right, and if we could define that task in an init container, basically Rook could enable this init container as a one-time thing, and then just disable the init container later, potentially.
But if it's a recurring event, it would have to be like a job.
Yeah.
If it's an upgrade path, then it's easy. We add it to the spec, and every time we restart the deployment, then we get through it. But if this is something after the upgrade that we would need to run periodically, then it would have to be like in Kubernetes. It's easy because we have jobs and we can schedule them on hosts and everything. And we just need to write the logic on don't do that on all the nodes and all the OSDs at the same time.
Yeah.
Essentially, it's like a cron, intelligent cron.
It wouldn't necessarily be like a recurring task. Like this might be a one-time thing. And it might be that the admin says, okay, go restart all my OSDs, and then it goes one by one. But you do that particular task once. It's not like you do it every month.
I think so it's more of a generic maintenance for OSDs, and then you put the task you want. So it's like super generic event, and then you put in it what you want to execute.
Do it one
like
time.
Reshard
yeah. And it'd be a one-shot thing where like you'd have to stop the OSD, then run the task, and then knit task.
If it's OSDs, then I guess we know that the logic would be go host by host or blah, blah, blah.
Probably, yeah.
Okay.
Or proceed by failure domain, right? With the new okay to stop.
Yeah, exactly. Yeah, I would probably want to follow the same logic as the other one. Yeah. Okay. And I mean, I think that the main question for me, I don't know if Josh is coming back or not, but the main question for me is whether having, oh, there you are. You just moved on my screen. Having like a small set of predefined and built-in support set of these tasks that you can do, like whether it's fscheck or reshard or drop allocation data or whatever it is, or repair, I guess. Bluescale repair would be an important one, perhaps. if that's sufficient, or whether we need to have it so that a power user could like construct some custom maintenance operation that they want to run. That seems trickier to try to.
Yeah, I mean, I think if the building blocks are in place, a power user could potentially use the building blocks rather than making the interface accept general scripts. But we also want to wrap something up in the upgrade process to run a general set of these, like during a major upgrade, for example.
I like the idea of the defining them as separate tasks, which a user can decide whether they want to do it as a part of the upgrade or later, as like a maintenance job. And initially we need to identify like resharding or format changes and things like that. But I can imagine like other Blue Store tool operations can also become a part of such maintenance operations.
Yeah.
They could be generic tasks where you need more knowledge than just saying, okay, run this task.
Yeah. I mean, yeah.
You can have like one wrapper that like runs all of these, and the user doesn't need to worry about which ones they need to use or not. Then it just gets all their OSDs to the latest and best settings, and other they could be built on top of these more specific general tasks that could be more customizable.
I'm thinking of this as we'd have some settings in the CR that say, do you want to enable this or this or this during the OSD restart? And then, so if you want to enable resharding, then we just enable that init container and restart the OSD. And when it's all done, then they disable it again. Or for more custom tasks, then it is more. That's where it's harder with Rook because you probably need to go stop the Rook operator and then do surgery on the OSD or stop it.
Well,
that's where it's more difficult.
I'm not sure it's a given that this has to be something that's reflected in the CRD. Because this could be something that the Ceph manager module drives, right? So if there's a way for the manager module to tell a specific OSD pod to stop, and then to just as a one-time thing run a job on it and then start again, like if it can do that sort of.
That would make the manager module mandatory for Rook deployment, and that right now it is not.
Well, only for doing these tasks. Like if you want to do a Blue Store repair, for example, then the manager module will drive that and have to drive that. Rook wouldn't necessarily have to do it, right? Like, right. I mean, I think what we want to avoid is a situation where we have to re-implement like so say we have this primitive where you can this basic capability and Ceph ADM even where you can stop a daemon, run some maintenance operations, start again. Immediately, the next thing you do is on top of that, build something that looks similar to the upgrade where you're gating based on OK to stop and doing this across the whole cluster and iterating across the whole cluster. If that's implemented in the manager, like we don't need to re-implement the whole same thing in Rook if we can just make those low-level operations something that you can do through manager Rook, right?
I think we can do it like simply by we can have init containers that we only activate and deactivate, just like Travis said, and then the manager module can just look up what's the pod name and then set an environment variable, which will effectively restart the deployment, and then go through all the init sequences and then activate the desired maintenance containers.
Yeah.
And once done, set it back to. Yeah.
Right. I feel like we could have similar patterns. Easy. The operator or the manager could pick up some patterns where it's acting as sort of a mini operator.
Yeah.
Right. Where it does something as a one-time task instead of the operator, which maintains the desired state.
Yeah.
And if it's advanced, we might want to send them to the toolbox to just say run this command or from the dashboard, whatever. And we don't support it from the CRs because it's advanced or whatever.
And it's awkward to reflect a one-time task and desired state in a CR.
Yeah, exactly.
It just doesn't make any sense.
Yes.
Yeah.
Okay, that sounds like a pretty good way to go for Rook then. Are there any concerns about it running this same kind of thing for Ceph ADM?
I think it's a little bit easier on the Ceph ADM side.
We have that logic to everything already. We just need to expand it.
Mhm.
Okay, so I guess once you have like a blueprint or a PR for Ceph ADM, just like highlight us, and we can go ahead and simply add the relevant init containers. But then someone has to write the manager logic to find out, okay, which OSD ID is which pod, and then go ahead and kubectl the write command or just call the API, whatever. And then this will trigger the maintenance on the OSD. But then at this point, the manager will have to drive between OSDs because this is really out of Rook's control at this point. So we just provide the facilitators for init containers, and then you execute them. I think it's a good pattern because you go into the toolbox. If you go with the CLI, you just Ceph manager, do like orch, daemon, repair. That works.
Yeah.
That sounds good. I think that covers it for that topic. Thanks.
Yep. Okay. What else? What are the other like key gaps on the manager Rook side? I mean, there's stuff like iSCSI. Does iSCSI matter in the case of Kubernetes?
I don't know, but I just wrote that because for me it doesn't really make much sense, and I just know or at least I remember how hard it was to implement it in containers. It looks like somehow it's successful for Ceph ADM, but I just don't really want to go back to that experience. But if we are looking at bringing parity between like the manager interfaces, then why one would have iSCSI and the others won't, or something? I guess is the question.
Yeah. Yeah, I mean, things like NFS and iSCSI only make sense if you are providing storage to something external to Kubernetes. At least in my brain, maybe I'm missing something, but and in that case, like I'm still fuzzy about what how that actually works. Like if Kubernetes has this whole like virtual networking layer, and you're providing a service IP, is that IP accessible to systems outside the cluster?
Yeah, you have routes that you can expose. So potentially a cluster next to the Kubernetes one could consume resources. Like RW endpoint, for example, is one example. You have routes for SSL routes for RW.
Is that something that's sitting on top of the service?
Yeah, it's a different service, but yeah, it's to have a router.
Yeah, so Rook just creates the service, and then depending on if you're using routes or there's a few different things, load balancers, the cloud providers add different ways to connect the service to the outside world.
Okay.
Yep. So all we've really worried about in Rook is just the service, and then people connect it how they need to. And NFS is a scenario that people ask about on occasion, not frequently, I'd say, but they are interested in that. I haven't heard much about iSCSI.
Maybe NFS would be I think making sure RGW and NFS work is probably would make the most sense. Sorry, maybe this is another stupid Kubernetes question, but in the case of a service, like if you have an RGW object store CR, and you say I want 3 RGW daemons, and there's a service associated with that, that service has one IP associated with it, right? or is there a service for every instance of the daemon?
So yeah, it's one service and then Kubernetes round robins between all the pods that match that service.
Okay. So when another container needs to access it, they'll just get randomly mapped to one of them, essentially.
Right.
Okay. And then if you specify a route on top of that, then it's going to deploy HA proxy or something, some load balancer plugin is going to.
Yeah.
Okay.
Exactly.
Okay. I wonder if that's something that this is backing up a little bit to what we were talking about before with the sort of having parity between what Ceph ADM is doing and what Kubernetes is doing, but maybe it's the route that's actually the moral equivalent of a virtual IP and HA proxy on the Ceph ADM side.
For Robin DNS, we need some kind of either have access to the network of the surrounding Ceph cluster, or we have to do some kind of virtual networking within the cluster. That was the main reason we discarded drone Robin DNS back then.
Yeah, I mean I wasn't trying to go there. What I'm saying is that right now when you deploy through the orchestrator API, if you deploy an RGW spec, right? On Ceph ADM we're going to deploy N RGWs, and on Kubernetes we're going to deploy N RGWs plus the service abstraction. But the service abstraction doesn't actually let an external user access RGW with load balancing or anything like that. You have to have the route in order for that to happen.
No, you once you get the service, then it just like terminology wise, the service IP is the VIP of KeepAliveD, if you will.
Okay.
Because
so
then
route,
at this point, and then the route is just something that it's like exposing, like opening the port. It gives you like a public IP if you want or something.
Okay.
It's like opening up the layer to the outside world.
Right. But I think that might be the same. I think that's what I'm saying. Like you don't get the external world can't access it until you deploy through the route, basically, and you specify that external IP.
Yeah, and the outside world is anything not inside the OpenShift or Kubernetes is the end. Yeah.
That virtual network. Yeah. So I'm wondering if that is the equivalent of on the Ceph ADM side, if we deploy the RGW service and we optionally specify that I want this virtual IP, that means that somebody outside can access outside the cluster. Like there's no virtual networking, so inside outside is a bit fuzzy, but
I think the reason why you have a VIP is because you want to bring HA to a HA proxy.
Right. Yes.
So you kind of need it. You kind of need that one, even if this means exposing to the subnet, I guess, where the VIP is running on.
But in the case of Kubernetes and Rook, like you don't have HA proxy until you create the route.
Honestly, I don't know. It really depends, I think, on the CNI and on the plugins. Yeah, so I maybe already know. I'm not sure either.
Well, Kubernetes is an internal DNS, so it could be that you actually have like one external IP, and then there's like the virtual addresses with DNS that are load balanced. The moment the service is up, you get the external IP. It's like a VIP. It's not really a VIP.
I guess to make
basically each RGW pod will have like an internal IP that Kubernetes knows, and then Kubernetes DNS, when you get your request to the external IP, does some load balancing and choose one of them.
Well, you don't go through HA proxy at all, right? Unless it's set a separate service for that, and
Yeah, you can do a load balancing service that will happen. Yeah, not okay.
Yeah. Okay. Well, I guess what I'm getting at is that it could be that it seems like we have two options. It could be that external IP or virtual IP or whatever property, that optional property on the RGW spec that you're passing to the orchestrator later. It could be that in the Ceph ADM case, if that's specified, then we deploy a keep alive D and HA proxy, so we get that single IP that you can hit with HA, and that triggers the whole HA framework. And in the Rook side, if you don't have that, then it deploys the way it does now, where you just have a service and you can access the service internal to Kubernetes, but not externally. And if you do specify that property, then you get a route, and then you get all the external access. And from a high level 10,000 foot view, they mean the same thing, right? You can access that service from outside of the cluster, whether it's the Ceph ADM cluster or the Kubernetes cluster, which is with HA.
As long as we don't, we have feature parity with Ceph Ansible, right? Where Ceph Ansible provides a lot more in-depth configuration options than just the IP.
Right. Well, so the second part of that is that because it's optional in both cases, I was getting all wrapped up inside because in the Rook case, it was like not optional. It was always deployed, the service was, but I didn't realize that there was this extra route piece that is optional for the external part, and that more logically maps onto the HA.
It happens on different layer, right? The route. So if you want to do SSL termination, for example, it's not going to be equivalent.
Well, in the case of the route, like in the Kubernetes case, SSL termination is going to happen on the route, basically, right, and not on the.
Yeah, because as far as I remember, once you create the route, you have to specify that it's SSL terminated. You have SSL options for that, so the TLS will be enabled. So yeah, there will be some SSL termination magic happening.
Is it possible to do SSL termination on the service? That's just like never done.
Well, the service mesh
We
has
do support
MTLS, but and that will actually make the connection between pods inside of Kubernetes with SSL. But usually it's up in the route.
Okay.
Well, it's very slow.
Yeah, Rook does allow you to specify the SSL cert for that we start the RGW service actually with. But most people, I think, just do their own termination or at a different level.
So I guess the punchline is then if that's the case, then we could have the HA piece of this be a separate logical service at the orchestrator layer, similar to where I was going before, so that you deploy the RGW service or the NFS server through the orchestrator layer. You do Ceph apply RGW blah, and that just deploys the daemons. And then separately, you do Ceph apply HA or route or whatever you want to call it at the orchestrator layer. And that maps to the Kubernetes routing stuff and the Ceph ADM keep alive D HA proxy.
Why won't you get the HA like straight away?
What's that?
Why won't you just go with the HA approach straight away instead of having to deploy a router's gateway, then enable HA if you can get it for free and then add more HA proxy and add more RGWs on top of it?
Because today there are cases where users don't want Ceph ADM to manage that for them. They do it on their own. Like they just want Ceph to deploy RGWs on these hosts on these ports, and then they're using their.
They will have their own load balancer
or something. Yeah,
okay,
exactly.
Okay.
I think the other advantage to doing that is that you can specify a different placement. So it might be that your RGWs are on these nodes, and you specifically want your HA proxies and your virtual IP stuff to be on these specific two nodes or whatever, because they happen to be connected to these two networks or whatever it might be.
Yeah, you could use the HA proxy some kind of as on gateway nodes. Or I don't know.
Yeah, the Keep Alive daemon. You need to install the Keep Alive daemon in the same host that you have the service. Okay. In our case, the RGW daemon, but you can move the HA proxy daemons wherever you want. Okay, in order to just to go to the virtual IP.
Mhm.
Really? Okay.
What do you think, Sebastian? This is sort of the opposite of what we decided an hour ago, right?
My problem is that I don't have made my mind about RGWHA. I just hadn't had the cycles to in-depth look into that topic. And I think both options are okay. Having it as a separate entity makes it more cumbersome to deploy it as a user. Having it within the RGW service makes it going to be more cumbersome or makes the RGW specification a lot more complicated, as we have to have a lot of settings for that specific we need to have, I think it's half a dozen properties for that HA thingy in Ceph ADM right now. So I think having it as a separate entity makes sense, as it is more, I don't know, modular.
Yeah. I mean, I think that the same set of issues come up that I was tripping over before, where like, do you always combine? Is it always a combination of Keep Alive D and HA proxy bundled together as a unit? Because then you can deploy those anywhere and they can point to a service. Or do you want to make it possible to do like active passive with just a virtual IP? Or
yeah, we have an WHA service that is specifically designed for our specific use case, and it's not yet a generic piece of code that can be deployed anywhere what you want to do with it. And I don't know how we can make it split it out into different parts that are more independently usable. That's easy with Kubernetes, because Kubernetes has deployments and services and pods and stuff like that.
virtual networking.
And virtual networking. It's a bit more cumbersome in Ceph ADM because we don't have those abstraction layers already provided. We have to build them our own. And we always have to find the balance between keeping it simple, keeping it especially crafted for Ceph ADM on the one hand, and on the other hand, making it more modular and to some degree re-implementing Ceph ADM, re-implementing Kubernetes and Ceph ADM. And we always have to find a balance. At some point, we implemented those specification files because the CLI was just not great. And I think we have to do that here again. Kind of providing different layers of that thing. One user interface that's maybe RGWHA, and then also providing access to the lower level objects for Keep Alive D or HA proxy independently.
I guess the problem is that if you start deploying HA proxy and Keep Alive D, then not only you become like yet another installer, not a Ceph installer. It basically crosses a bit the boundaries of what CPDM should be doing. Honestly, I've always been against having HA proxy as part of Ceph Ansible, just because HA proxy already exists on its own as a rule for Ansible, just like KeepAliveD does. And embedding it into the product always felt a little bit wrong. And I guess the problem is that once you start doing this, then those two have so many configuration options or so many ways it could be deployed / configured that you would just end up maintaining that forever. Because as soon as you start doing it, then people will keep asking for more and more and more. And you never, like, you can just not say no to you doing it or accepting contributions anyways. So it's almost like...
It's almost like a Helm chart. The inevitable fate of a Helm chart to be enormously complicated in just replicating the configuration file of the service it wraps.
Yeah, and you can just like keep the stance today that you only deploy Ceph components. And if you want to bring HA to RHW, then you need to have a load balancer somewhere.
Yeah, I think it's just you can't do that and like also make the system easy to use, because at the end of the day, somebody deploys Ceph and they're just like, where do I point my NFS client? Like, I just need an NFS endpoint. And obviously it should be HA because like, whatever.
Yeah, I understand. And I know it's a difficult decision, but all the consequences, we know them. We have been through them because of Ceph Ansible or thanks to it. I don't know.
Well,
it's just
yeah. I guess it feels to me like having that HA like component module be an optional thing that we can deploy or not deploy gives us a bit of an out, because we can deploy it in a reasonably opinionated way, support for HA proxy, then deploy it yourself. And these are the hooks, so you can figure out what the discoverable endpoints are that your HA proxy points to. And so, yeah, you can kind of go either path.
Yeah, but the thing is still always the same. Like, where do you draw the line?
Yeah. Yep. Nice.
Because one day it makes sense, then the day after it doesn't make sense anymore, and it keeps going like this. So it's difficult.
Yeah. Okay. Well, are there any other Rook items that it makes sense to cover?
I added one more to the agenda there, just to, I don't know that it's a big topic to discuss, but bucket provisioning with the COSI or Container Object Storage Interface, I think it's called. That's coming soon with Kubernetes 1.21, I think is the first release with it. And Rook will be basically providing a storage class that lets you easily provision buckets, right? I just don't know if there's anything that would make sense as far as the dashboard, or maybe it's already being done, or bucket provisioning is an area that community is interested in. But is there anything that needs to be done at a different level as well for Ceph ADM? I don't know. Any thoughts on that? Or maybe Blaine has a thought. He's been more involved.
I guess my thought is I hope we find a time to like prioritize integrating with that in this coming year, because I think even though it's going to be in alpha, I think that's something to get started with earlier. It's pretty clear just from the number of issues and questions that we get about object bucket claims that it is something that people are using upstream. And I think COSI is it's going to be the official Kubernetes way to do it. That said, I don't see a direct analog of that to Ceph ADM, because it's like a Kubernetes, like my application wants object storage, I'm going to request it, and then there's a sort of implementation layer in Rook that will then go to Ceph and say, create my bucket, create my user. Yeah, so I guess my thoughts are mostly like I think this is a priority we should have for Rook in the coming year. I don't see it being something that we need to think too hard about for Quincy. Although I think there are certainly things we could talk about, especially as it comes to like brownfield buckets and things like that, like how to handle, like what happens if a bucket exists. It's kind of hard to know from the Rook side of things. It's like, okay, this, Cozy has requested a bucket. This bucket already exists, but it's hard to know if that's because Rook already created it or because it's pre-existing. So there is maybe, actually, now that I start talking, something we could talk about, whether there's like meta information we can put on buckets and bucket users to identify like how they were created, or like by what mechanism they were created. That way in Rook, we can tag something like, oh, Rook created this for this Cozy bucket. This is the same request coming in. We know we can just continue on, but if it was created with a different mechanism, then maybe we want to flag an error and say, this bucket pre-exists. I don't know how much of a concern that is in reality, however.
That's a timely question since we're just bleeding into the RGW section. Is there is there an appropriate place to put metadata like that on an RGW bucket?
That's a question I don't know the answer to.
I don't
think
remember.
you can write user-defined metadata to buckets.
Can you?
Is it just objects? I'm not sure.
I think if I remember correctly, the interface was just for objects for S3, but Swift might have allowed that, so we probably allowing that. I'm not sure. Need to check the API.
I'm not aware of it being a supported feature. I mean, if it's an extension, we haven't properly documented it.
How big is this metadata? Does bucket tagging work?
I guess my thought is the metadata would be really just enough information to say the source of something. It would be a string that's, I don't know, 64 characters long, maybe 128 characters long.
It'd be like the Cozy request ID or something like that.
You can set an echo.
Yeah, it would effectively just be like something to indicate, like to cross-reference it is from a request from Cozy or from object bucket claims that we currently have, just to say, okay, the object bucket claim is this name in this namespace, which I think is like 128 characters of meta information.
Something to investigate at the very least.
Yeah, need to do some investigation there. We have some place to put extra metadata, but we maybe not a good idea. Like to have a generic space there for metadata that could be abused.
Well, I don't see how it could be abused more than object metadata. It sounds like a proposal should follow to well-defined bucket metadata. I mean, that can be argued against, but I think it's a good idea. It sounds credible.
Yeah. At the list, you should check. There might be the Swift API might have allowed it, and so we might already support it, but I need to check.
And then document it.
The use case sounds a little strange, provisioning buckets on a brownfield cluster that has other important stuff on it, presumably with the same users also. I mean, if it was a different set of users, then you can't recreate a bucket that was created by a different user. So that might be a way to avoid the conflicts.
Yeah, the whole premise whether we shouldn't allow recreating a bucket is gonna. I wasn't sure. Why wouldn't you? Like, if it's the same user, then it's fine. If it's not the same user, you can't really do it anyway.
Right.
As Casey noted.
I mean, I think the big question in my mind is like sort of related is whether Cozy has a type of brownfield interface where what you're not claiming a new bucket, but you're claiming access bucket. That's something
Yeah,
that
it does have.
Cozy definitely does, and the current like sort of proof of concept that we have with object bucket claims also has a brownfield case. So yeah, I mean it's also like something that in the implementation in Rook we would need to know if it is a green or brownfield case in order to know whether checking is something that we actually should do or not. And yeah, I guess this idea isn't like doesn't have full fruition. I just know that in Rook there are even just outside of object storage, there are times when it would be helpful to understand like what the source of something is, whether it's a like configuration or I guess mostly configurations is what I'm thinking about is like what initially created this thing or modified this thing.
Yeah, I still think that isolation of RGW users is going to be important there. It doesn't seem like in a brownfield cluster, Kubernetes should be having users that have access to data that it hasn't created itself.
I'm not sure. No,
I'm not sure about that at all.
Yeah, I'm not sure either.
Yeah, me
Because
too.
we have a mode where we can connect to external gateways. So we can actually consume external already running gateways. But then if that's the case, we could allow new users to consume existing buckets from an outside, from an external cluster.
Yeah,
Okay. Sorry, go ahead.
no, actually, with the right bucket policy, there may be that you want to share bucket across different application, different platform.
And the OBC implementation libbucket provisioner did, in fact, uses bucket policy and edits it and elaborates it over time to adapt.
Okay, so that's the use case exposing existing buckets via claims?
That's a use case.
One could be just moving to different implementation.
Okay, well, it seems like either you allow access to everything or you have some method to explicitly opt into certain buckets.
I think some of this discussion is probably good for offline, but I'm really glad to have started the conversation going. It might be worthwhile for me to jump in on the next call as well. It sounds like since that's RGW, to potentially talk about it a little more.
So Blaine, I missed the beginning part of this. I apologize. Are you working on Cozy's implementation?
Currently, no. I guess mostly my concern is integrating Rook with Cozy.
Well, Jiffin Photon is working on that and would probably love to talk to you more if you haven't already.
And I saw Jiffin reached out on the Kubernetes Slack to the code, and I told Jiffin he could ping me with any questions that I can ask during the Cozy upstream meeting things. And I've been trying to follow those as the past few weeks have been a little crazy for me, but I'm really happy to have Jiffin's help doing that because it's also I just have so many things to.
Well, I think vice versa as well. But that sounds really helpful, and I appreciate it.
Yeah, thank you. I also appreciate all of the like knowledge that all of you are bringing about RGW and object storage, because that's not something I have a like great depth of knowledge into. But as far as integrating it with Rook, I also have spent some time looking at the libbucket provisioner and like how Rook interacts with that, and have rewritten some things recently. So I at least have like some recent knowledge about like what has gone on and what I kind of found there.
Thanks, Blaine.
Yeah,